Alright, this is Mr. Wynn. Today's video will be operations with matrices. So a matrix is a rectangular array of variables and constants in rows and columns. So it's just a lot of numbers organized in rows and columns. Rows are sideways, columns are up and down, they're vertical. So in a matrix, the numbers of data is organized so that each spot has a purpose. Every spot inside or every number inside is an element. We usually name it with the uppercase letter, for example, A. And every matrix has a size, dimensions. It will be the rows by column. So A has 3 rows and 4 columns. So A is a 3 by 4 matrix. Alright, so matrices are extremely helpful for solving simple to very complicated equations, including systems of 2 variables, 3 variables, 4 variables, etc. And I'll show that later, but today's video will be adding, subtracting matrices, and multiplying matrices by scalars. Scalars are just numbers, like constants, like multiply by 5, multiply by 10. So, multiply by a constant. It could be a fraction or a decimal. Just multiply by a single number. Adding, subtracting matrices, make sure they're the same size. For multiplying by scalars, size does not matter. Alright, so find A plus B. Well, A is a 2 by 2 plus B. B is also a 2 by 2, 2 rows, 2 columns. So this is allowed. I can do 16, 2, negative 9, 8 plus negative 4, negative 1, negative 3, negative 7. Now, when you add them, it's very simple. Where the spot is, add that number in the same spot. So, this top left spot, I have 16 and negative 4. 16 plus negative 4 is positive 12. On the top right spot, 2 plus negative 1 is positive 1. On the bottom left spot, negative 9 plus negative 3 gives me negative 12. On the bottom right spot, 8 plus negative 7 gives me positive 1. That is the answer. Alright, the second one, again, A is a 2 by 2. And we're trying to add C, which is a 2 rows, 1 column, 2 by 1. Now there are different sizes, so this is not possible. No solution there. If you tried, you wouldn't know what to add to A's 2 and 8, because C only has the top left, bottom left. It doesn't have a second column of numbers. Now subtraction is the same idea. So A is a 2 by 2 minus B, which is also 2 by 2, so this is allowed. Now technically, I'm going to get ahead of myself here. There's no such thing as subtraction for matrices. It's just adding. So I'm going to treat this as a scalar. So here's how I'm going to write it. 16, 2, negative 9, 8. Instead of I'll put a minus 1 here and put B. B is negative 4, negative 1, negative 3, negative 7. Now I highly recommend y'all put that negative 1 there. When there's a number in front of a matrix, again, that's a scalar. All you do is distribute to every single number inside. So really, here's my new problem. So this is still 16, 2, negative 9, 8. And it has a plus sign. Well, negative 1 times negative 4 is positive 4. Negative 1 times negative 1 is positive 1. Negative 1 times negative 3 is positive 3. Negative 1 times negative 7 is positive 7. Now I can add this simply. People always mess up when there's a minus sign in the middle. So 16 plus 4 is 20. 2 plus 1 is 3. Negative 9 plus 3 is negative 6. 8 plus 7 is 15. And that is my answer. Alright, so example 2 is kind of what we just did. If R equals that, R is a 2 rows, 3 columns. It's a 2 by 3. Find 5 times R. So 5R is just 5 times all this. Negative 12, 8, 6, negative 16, 4, 19. So all I'm going to do is distribute that 5 to every single number inside. So I get negative 60. 5 times 4 is 40. 5 times 6 is 30. 5 times negative 16 is negative 80. 5 times 4 is 20. 5 times 19 is 95. That's my answer. Again, when you multiply a scalar by just distributing a number, the size of the matrix does not matter. You just distribute every single number inside. There goes the 6. Alright, and last, it could be a combination of both. So if A is that and B is that, fine. Negative 4 times B minus 3 times A. So A is a 2 by 2. B is also a 2 by 2. Since they're the same size, I'm allowed to do this. If one of them was a different number, I could stop right away and say no solution. So negative 4 times B. B is negative 4, negative 8, 2, negative 3. And minus 3 times A. Well, A is negative 9, 12, 2, negative 6. I distribute to both. So I distribute negative 4 to everything here. That gives me a brand new one. That is 16, positive 32, negative 8, positive 12. Now here I'm going to distribute the negative 3 and make it addition. So really adding, negative 3 times negative 9 is positive 27, negative 3 times 12, negative 36, that's negative 6, positive 18, and now I just add them spot for spot. The top left spot, 16 plus 27, is 43. 32 plus negative 36 is negative 4. Negative 8 plus negative 6 is negative 14. And 12 plus 18 is 30. And that is my answer. So here's your practice problem. Try it. If you can get it right, the pre-quiz and the quiz should be easy. All right, see you in class. Thanks for watching.